Today we're going to talk about section 2.1, equations in two variables. Equations in two variables are going to have a y and an x. Okay, so these are going to be y equals equations eventually, and we're going to look at the forms that they could take on and some of the graphs that are associated with it. So look at this. We're going to first talk about slope, and as you recall, slope is a measure of the amount of rise over the amount of run. Okay, so it's the change in y over the change in x. So it tells us how much is going up versus how much it's going over. The formula to do this is going to be y2 minus y1 over x2 minus x1. Okay, so we're going to measure the amount of change in the x and the amount of change in the y, and we're going to make a ratio. Well, a lot of times slope is denoted using the letter m. So m is used to define slope. You've probably heard y equals mx plus b, which we'll talk about in a minute, but slope is measured as m. So let's look at the forms that the equations can take. When we're talking about equations in two variables, we can have a couple of different things, and the forms are going to be useful for different purposes. And so as you go on in your math career, slope-intercept form has kind of been something we've used a lot, but then as we talk about moving into more of calculus and upper level mathematics, point-slope form is going to become more and more useful for certain things. And so slope-intercept form is y equals mx plus b, where y and x are some point, and obviously the m, as we just talked about, is the slope, and the b is the y-intercept. And because of that, you know, the slope-intercept form, if you forget which letter is which, it goes in the order that it's set in the title of this form, slope-intercept form. Now this can come in several different variations, so you might have to solve for y, but eventually you'll get a y equals mx plus b. Point-slope form, on the other hand, is something that, like I said, can be useful more for calculus, and what we're looking at is y minus y1 equals m times x minus x1, and x1, y1 is a point on the graph of the line. Okay, so it's going through that point. So this equation goes through that point. And so obviously we have m here again, that's the slope. And given that point, that's going to help us determine some things that we can use it to find the intercepts, or however we need to work to be able to get everything that we need information-wise. Okay, so those are the two forms we're going to work with primarily in this section. So as we look at graphing these equations, we need to do a little bit of review, and you can see that I have a couple of equations here. And what we're going to do first is I like to outline my slope and my y-intercept. You might be able to do this in your head, but I want to be able to show you. And so having the slope and the y-intercept are going to help us graph this pretty easily. So when I look at my slope, that's the number in front of x, so that's going to be my 2. I'm actually going to write it as a fraction 2 over 1 to give me rise over run. And my y-intercept is going to be 1. This is all the information that we need to be able to graph this equation. So let me do a sketch here of a coordinate plane, and I'm going to show you how to determine where this graph goes. First of all, we're going to use the y-intercept. So we're actually going to use them in the reverse order of the way they're listed in the equation. So now I have 1 point. Really, I only need 2 points to be able to sketch a graph, but because I've got this 1 point and I know the slope, so I'll use the slope next, I can determine an infinite number of points, but I'll use 3 for this scenario. So I'm going to go up 2 over 1 to get to my next point. And then I'll go up 2 over 1 to get to my next point. So as I draw this sketch, that's my graph. So I determine my y-intercept, plot that, and then I use my slope to walk to other points. And so if I was going to go up 2 over 1, I'm back on that graph again, okay? And so the slope is going to be able to have me walk those steps up and over to get to an infinite number of points. In my next one, my slope. Slope here. Well, I don't have an x, so actually my slope is 0. Because imagine this as y equals 0x plus 2. Well, my slope is 0, and so my y-intercept is 1. So what does this look like as a sketch? Well, if I plot out my points, really I'm asking the question, where does y equal? Should be a y-intercept of 2. So where does y equal 2? Well, y equals 2 right here. That's my y-intercept. Well, if my slope is 0, what does that mean? Well, it means there's no rise for all of the run. And so really the way that I like to think about it is, y equals 2 at all of these places. And I don't go up any, so my slope is really 0. And so y equals 2 is a horizontal line, because my slope is 0, meaning it goes up none for all of the amount of rise. And really at all those points, y equals 2. One more example. Now this one you're going to look at and see that it's not in slope-intercept form yet. My x and my y are on the same side. So in order to get it in slope-intercept form, I need to solve for my y. And so I'm going to end up with y equals negative x plus 2. Well, as you can see now, I end up with something that's in slope-intercept form. So my slope is negative 1. That's the coefficient in front of x. And my y-intercept is 2. So as I go to sketch, I will put on my y-intercept here, and I'm going to go down 1 over 1. I'll go down 1 over 1. So my sketch looks like this. Okay, and so my graph has a negative slope. It's going down and to the right, and that's going to give me a good idea of what that graph in general is going to look like. Okay, so that's the basic gist of graphing. As we look at the next one, we're going to be finding slope through points. Well, we remember our equation is y2 minus y1 over x2 minus x1. So the change in the slope. So I can do 1 minus 0 over 3 minus a negative 2. And so my slope ends up 1 over 5. Let's say you couldn't remember the formula and you thought it was y1 minus y2 over x1 minus x2. As long as you keep them straight, what should happen is you get the same answer. So I have 0 minus 1 over negative 2 minus 3. So then I'd end up with a negative 1 over a negative 5, which equals 1/5, the same exact answer. And that's going to be true as long as you keep your points together. So as long as you subtract the second one from the first one or the first one from the second one, you should be okay to get the correct slope. Finding equations. We're going to do two sets of problems here, finding equations. The first situation is this, and this would be a good thing to write in your notes. We have slope. And a point. Okay, so later we're going to do a different situation, but right now we have slope and a point. And so if I'm looking at point slope form, I know that I'm going to write down equals negative 3/5 times x minus 5. If I clean it up, y plus 1 equals negative 3/5 times x minus 5. That's one of my answers. My other answer is going to be found in the same way. I'll plug in everything that I can and solve for what I still need. So I'll use negative 1 equals negative 3/5 times 5 plus b. So negative 1 equals negative 3 plus b. So I'll add 3 to both sides to solve for b. 2 equals b. So therefore, when I get down to the end, y equals negative 3/5 x plus 2. So I found my two forms of my equation using that information given. So it just depends on what your situation is. In this case, we had the 2 points, so we had to find the slope. In the previous example, they gave us the slope. So that's kind of the gist of what's going on here. Let's look at another piece of information. Parallel and perpendicular lines. Parallel lines run like railroad tracks, and so slopes are equal. So if you're given a slope, to find a parallel line, you just take that same slope. Perpendicular lines are going to intersect at a 90-degree angle, and so the slopes are going to be opposite reciprocals of one another. Opposite reciprocals. So, for example, if I have m equals 3/2, a perpendicular line to a line with that slope has a slope of -2/3. Okay, so 3/2 -2/3, so you're going to do the opposite reciprocal. As an example of this, we're going to find a parallel. So find the slope-intercept form of the lines that pass through the point 2, -1, and are parallel and perpendicular. So I'm going to do two situations. Here's the parallel one, and here's the perpendicular one. Well, first, I need to do a little bit of rearrangement because I have this equation here. So if I am going to try to work with this, I need to figure out what this actually would be in slope-intercept form. And so I'm going to rearrange my canvas here a little bit. And we'll do perpendicular here because I got to do a little bit of work over here. If I've got 2x minus 3y equals 5, then what I can do is I can just solve this for slope-intercept form. Equals 5 minus 2x divided by -3, and I do that just by solving for y. So y equals 2/3 x minus 5/3. Okay, so I had to make sure to divide each part of the numerator by the denominator. And so what I've got now is my slope that I'm comparing to is 2/3. And so you can immediately know that the slope on your line for parallel is going to be 2/3, and we can know that the slope is going to equal -3/2 over here because it's got to be perpendicular. And so if I'm going through the point 2, -1, I'm going to work this way. Start with my formula, y equals mx plus b, and I'm going to plug in everything that I know. So -1 equals 2/3 times 2 plus b. -1 equals 4/3 plus b. So I'll subtract 4/3 from both sides because I'm trying to solve for b. And so over here, I end up with -1 minus 4/3. So -3/3 minus 4/3, because I converted the -1 into thirds, equals b. So this is -7/3 is b. And so my equation is going to take into account my slope and my y-intercept, slope-intercept form. So y equals 2/3 x minus 7/3. So I used my slope that I figured out from my original equation over here, and I used my intercept that I solved for. A perpendicular line is going to be much the same way. So we're going to start with our formula, y equals mx plus b. -1 equals -3/2, and that's the change here because I changed my slope, times x, which is 2, plus b. So it's just a matter of simplification again. So I've got -6 over 2, so negative 3 plus b. So I'll add 3 to both sides. So 2 equals b. And so in this case, now I've got my slope here and my intercept. So I'll go y equals negative 3 halves x plus 2 for my equation. It's all a matter of getting the pieces in the right place. So if you know the equations, you plug in what you have, solve for what you don't, and then simplify later. That's all there is to it. That's the basics of linear equations in two variables, writing them in a couple of forms and using slope and intercept. Thanks for watching, and we'll see you next time.